before we dive into this, I'm going to grab a blank sheet of paper. I would encourage you to do the same. I'm going to do a quick review of what we went over Tuesday. Again, yesterday was a catch-up day. Some of you utilized that to the max. Some of you were marked absent. So on this blank sheet of paper, and again, I would grab a blank sheet of paper outside of your notebook, and I'll put that Desmos code right in the chat for you as well. All right. So on this blank piece of paper from Tuesday, we talked about the locus definition. So I would start off with a concave up parabola. So you've been dealing with parabolas all the way since as early as 6th grade, maybe even drawing the shape. 8th grade, you learned a little bit about the complexity of it with x squared. 9th grade, you really started to dive into it. But believe it or not, every single parabola that you have ever drawn has these two features. You just didn't know. They're like almost invisible. Okay, the two features that exist for every single parabola is this line and this point. Do you remember the vocabulary term for this line? The line is called starts with a D, anybody? Thank you very much. That is the directrix. Remember the directrix? I showed you the real life example of the metal shavings. It really, think about it like a magnetic force field. You cannot cross that directrix. It's pushing all this parabola, or if you thought about the metal shavings, up and around this point. This point, the parabola is bending around. What is that point called? We have the directrix and we have the focus. Good. Or sometimes referred to as the focal point. And then every single parabola has always had a vertex. And remember, this works exactly the same way if it was concave down. I have my focus, I have my vertex, and I have my line, which is my directrix. Now, the part that I need to stress is we figured out that the vertex, because what you started with on Tuesday was this line and the point. So you started with the directrix and the focus. We found that the vertex lies right in the middle of the focus and the directrix. So if I started at the vertex and I went up this value, or I went down this value, I ended up at the focus and the directrix. Do you remember what variable that was? If I went the vertex up and the vertex down, what was that variable? P. I went up P and I went down P from the vertex. What P represents, unfortunately, it is Greek, which is why you don't see P in the words. It is called the focal length. The focal length is actually what determines how narrow and how wide the parabola is. So if I have my vertex, I can go up P, I find my focus, I can go down that value of P, and I can find my directrix. Please remember that P is always positive because it is a length, so it always has to be positive. It can never be a negative value. All right, so then how did I put this together in an equation? Remember, we did our last unit. We completed the square to put it into vertex form. However, most of the time, not all the time, most of the time when we put it into vertex form, our A value is 1. But as I showed you on Tuesday, it could be a 2, it could be a 3, it could be a 4. All that impacts is how narrow or how wide. It could be a 1/2. So what we found out is that this A value actually has its own value. A is equal to 1/4 times the focal length. So my formula could also be written as 1/4p x minus h quantity squared plus k. So just a quick recap, a quick overview, then we're going to do pretty much for the rest of the class, examples, examples, examples. By the end of class, I will show you another manipulation that will set you up because not all Algebra 2 teachers teach this manipulation of the formula. Because I could subtract k, I could have multiplied by 4p. You can change a formula and solve for different things. I use this one because we know vertex form. So let's build on what we already know. Okay? All right, so with that being said, please remember when you're finding your vertex, remember your vertex is opposite, same. Your h is your x value, but you have to pull the opposite x value and then the same k value for your y. All right, with that being said, if I start off on number 3, because we started talking about this last class. On number 3, can anyone tell me why did I know or how did I know this was concave down? How did I know this was concave down? Alexis? Beautiful. Your A value is a negative A value, so right away it's concave down. So as soon as I knew it was concave down, do you see how I drew that sketch? All right. So now the next part is, can I find my vertex? Can I find my focus, my directrix, or my focal length? So now it comes down to my vertex. Now, pause for a second. Look here. Remember, A, all it determines is how narrow or how wide. So I can cover up A. Cover up that 1/16 with your finger. Do you see how you have this x squared minus 3? Does anyone remember with that x squared minus 3, if I had x squared, does that minus 3 move it left, right, up, or down? Remember, if it's outside of the x squared, it's going to move it left, right, up, or down. Which one do you think? If you were to take a guess, left, right, up, or down? You're right. Thank you. I appreciate it. All I asked is you had a 25% chance. Thank you for at least taking a guess. All right. It is going to move it down 3. Remember, if it's outside, remember I gave you that silly balloon analogy? If I took a balloon and I let go outside, it's going to go up and down. If I move it inside, it hits the ceiling and goes left and right. Okay, if it's outside, you're right, it's going to move it down 3. So my vertex would shift 0, negative 3. Another way to write this that people have a little bit easier time seeing it is anything inside the quantity being squared? No. So I could have written it as x minus 0 quantity squared minus 3. Then once you realize, oh, there's really a 0 there, opposite, same, opposite, same. So now my vertex would be 0, negative 3. All right, so first graph that. 0, negative 3, label it vertex. All right, now here's the next jump. Once I have my vertex, I can't find my focus and my directrix until I have my focal length. So my focal length is all going to be based on this A value. So I know my A is equal to negative 1/16. But what was A also equal to? Do you remember what we substituted that formula into? 1 over what? Look at your blank piece of paper. Thanks, Lexus. 1 over 4p. So if A is 1 over 16 and A is also 1 over 4p, what's your p value? How'd you get 4? 4. Yeah, it's 4 because 4 times 4 gives me that 16. So your p value is 4. Now I always have someone ask me, Ms. Carrick, but I thought A was negative 16. But do you remember how we said p always has to be positive because it's a length. If I gave you a ruler, you can't measure negative 2. So now I know my focal length is 4. So I'm going to go from my vertex up 4, 1, 2, 3, 4. I go down 4, 1, 2, 3, 4. But now here's where you have to be careful. This is why your sketch is so important. Look over here. If you go vertex up 4, did I find my directrix or did I find my focus? Directrix because it's concave down, right? That's why your sketch is key. So now I can draw that directrix at y equals 1. And that means this point down here is my focal point, which would be 0, negative 7. Questions on that? Please make sure that you're always drawing a sketch of a parabola, just a sketch. But as long as you have your directrix, your vertex, and your focal point. All right, let's go down and try another one. So let's move down to number 4 for me. All right, again, is it going to be concave up or concave down? Paul, concave up or concave down? Down. I agree. Concave down, how did you know? Your A is negative. Beautiful. So I know it's going to be concave down. Notice I'm drawing not only the concave down parabola, but also the directrix and the focal point. All right, so now I have to find the vertex. Remember, don't be tripped up by that A value. Cover it up. Cover up that A value. So wait, all that's left over is x squared. What's the vertex of x squared? 0, 0. It's the origin. It did not get shifted left, right, up, or down, so the vertex is your origin. Put a dot on the origin. Always label vertex. You'll see why in a moment that's so important. Then, again, we move from our vertex to find our focal length. So, again, it's about that A value. We know A equals -112. A is also from that formula 1 over 4p. Yes, I know some of you can look at the equation and tell me your focal length. You have to write this work down. So that means, Madison, what would your focal length be? If A is 1 over 12 and A is also 1 over 4p, p would be equal to what? Beautiful. Focal length would be 3. So I go vertex, I go up 3. 1, 2, 3. I go vertex down 3. 1, 2, 3. Alexis, when I went vertex up 3, did I find my directrix or did I find my focal point? Directrix because, beautiful, because it's concave down, which means down 3 would have been my focal point. So directrix, y equals 3. Focal point, 0, -3. Any questions at home? Anything that I can answer? Thank you for helping navigating through the booklet. I appreciate those of you who are helping each other out with the directions. Again, I apologize, these pages are not numbered.
Yeah, I get the process now.
Thank you. I'm glad. All right, so let's build on that. So we're going to go a little bit further. We're going to go a little bit deeper with the concept. So let's take a look at number 5. This is where things are going to get shifted up, but please circle what the question's actually asking. I am not giving you the equation, which is why things are going to get a little bit more challenging. I give you the directrix, I give you the vertex, you have to write the equation. So, visual graphic. Y equals -1. Please note when I'm graphing the directrix, yes, it should be dotted because it's not part of the parabola. My vertex is 0, 3, 0, 1, 2, 3. Label it with a V for vertex. First thing, concave up or concave down? Concave up or concave down? Concave up. If it was concave down, it would cross the directrix. Can it ever cross the directrix?
Never.
No. Think about it being like a force field pushing it up. I would come over and draw the sketch. So if I have my directrix, I have my vertex, I know my focal point's going to be up here. I know my vertex is 0, 3. I know my directrix is y equals -1. So I need either the focal length or I need the focal point. Andrew, any idea how I could find that focal length?
You could use the equation, the A equals 1 over 4p, but then again, I'm not 100% sure about that.
That would be true, but I don't.
Underneath it like that, P equals.
That's not gonna help me either.
That's the same one. Yeah,
In a moment. Think about visually. Remember, vertex up to the focal point is that P. Vertex down to the directrix is that P. Remember how I went plus P,
Yep.
minus P.
Yep.
So if I have the vertex and I have the directrix, could you tell me what your focal length is?
You probably boxes.
Count the boxes, exactly. Count the boxes, so it would end up being a focal length of 4. Meaning I know I went from the vertex down 4, so now I have to go in the opposite direction. I would then move up 4, 1, 2, 3, 4, give me my focal point of 0, 7. All right, now here's where it gets a little bit more challenging. I still am going to sketch my parabola, but now I need to answer what the question was asking. The question wasn't asking for the focal point. The question was asking, give me that equation. A, x minus h, quantity squared, plus k. But remember, A is also the same thing as this is where, Andrew, that 1 over 4p is going to come into play. Aiden, you keep turning your mic off. So I'd have y equals 1 over 4 times p. Your p is 4, so it's going to be 1 over 16. Then here's where you have to be careful. Remember, plug in your vertex, x for the h, 3 for your k. So it would be x minus 0, quantity squared, plus 3. You could have also simplified that to be y equals 1/16, x squared plus 3. 0, 3 for our vertex. All right, take a look at 6. I want you to try 6 on your own. At home, you're going to submit this to me on Desmos number 2. Use what we just did up above, and then you got to take it up another notch. Use as an example. Always draw a sketch. I will tell you that 6 is not the same thing as 5. It's similar, but slightly different. So be careful. Make sure you're labeling your diagram.
Did you get my warm-up?
Sorry, I stepped away from my computer for a second. I can check for you.
Miss Carrick,
Yes?
will the first number in your vertex and the first number in your focus always be the same?
Yes, because, and that was a really good question. If you take a look at this diagram, so what Arabella asked is, will the x value of your focal point and your vertex always be the same? Yes, because they always lie on your axis of symmetry. So that x value is actually the axis of symmetry of your vertex and your focal point. Yes. And then Arabella, yes, I got your warm-up.
It wasn't me that asked about my warm-up.
Oh, I'm sorry. It sounded like you. I was away from my computer.
It's okay.
Somebody else asked. I'm sorry. I was away. I was trying to guess a voice. Again, please make sure you are submitting this to Desmos. I've only got 3 of you right now, so please make sure you do submit what you have and then make sure you click to the next slide. All right, so I got us started. My first question, is it concave up or concave down? Come on, I need more voices. Is it concave up or concave down? Concave up, do we agree? All right, I like concave up. But now here's the catch. Number 5, I gave you the vertex and the directrix. Number 6, I gave you the focal point and the directrix. If I have the focal point and the directrix, would the vertex lie between the directrix and the focal point or outside of the focal point? Between or outside? Between, right? Where does it lie between? There's a specific location. Would it lie down here, the vertex? It has to lie right where? Right in the middle, halfway. So if you found the full distance from the directrix to the focal point, and you took half of it, you have your focal length. So I know to go from -5 all the way up to 3 would be 8. If I do half of that distance, I mean it's going to break into a focal length of 4 and 4. So that means if I go down 4, 1, 2, 3, 4, I found my vertex. And I can go down another 4, 1, 2, 3, 4, and it gives me the directrix. Which means I found my vertex as 3, -1. Are you okay with that part? All right, now challenge yourself to put it into that equation. Again, remember, y equals 1 over 4p x minus h quantity squared plus k. So y was equal to 1 over 4 times p would be 1 over what? 1 over 16. Please make sure you have your squared. I cannot tell you how many people forget they're squared. So it ends up being x, and then remember, opposite same, x minus 3 minus 1. Notice it was a positive 3, so it goes in as a minus 3, and then -1 goes in as a -1. And, of course, make sure you sketch your parabola. Questions on that one at all? Yeah, go ahead.
This way is better.
You like it like this one? Okay, it just depends, right? It depends if they give you, and it's going to depend in June. Do they give you the equation or do they give you pieces? All right. Then flip over, take a look at number 7. Try number 7 on your own for me. Careful about what they give you. They give you the focal point and they give you the vertex.
Do we post on decimals as well?
Of course. Number 3 for me, please. Please know there are some of you that I have not received anything from. If I'm not hearing from you, it's like you're not even there at home. I would rather you submit something and have it be completely wrong so we can learn from it than not try and do anything at home. Also, moving into this 3rd quarter, you will be submitting your notes to me on a daily basis through Desmos, because I'm noticing our notes are starting to be pretty sparingly. Remember, as soon as you graph, think about, is it concave up? Think about concave down. Draw yourself a sketch. What else do you need to find? And then make sure you're answering the question. Make sure you write the equation. We got about half online. I want to see how's it going. I told you it's gonna happen. All right, things are looking pretty good so far. So real quick, your focal length would be 1. Do we agree with that? So when I plug it in, that also means my directrix would have been -2 because I know it is concave up. I go up 1, I go down 1. So I should have ended up with an equation of 1/4 x. You could have done -0, or you don't need the 0 at all. Squared, and then same operation, -1. We're going to go over and take a look at question number 9, please. I'm going to get you started on question number 9 because you're going to notice how this one changes it up a little bit. Directrix 5. 1, 2, 3, 4, 5. Focal point 3, -1. As soon as you see this, again, I'm just coming over and drawing a basic sketch of it. What do you know right away? What jumps out at you about this diagram? What's different about this problem than any problem we've done before?
The P would basically be 0. Like,
The P
no.
is not 0.
Also in between. 1.
What's different about this problem than any problem we've done so far? My directrix is here. Tristan, go ahead.
The A value will be negative.
Yeah, because it's going to be concave down. Do you see why it's concave down? Remember, if it was concave up, that means the parabola would cross the directrix. It can't. I know here's my focal point, so my vertex, remember, is going to be halfway between, meaning, again, it's going to be concave down. Why that sketch is so important. So if I know my focal point's here, again, Andrew, this is where it's going to find that p-value. So if I go all the way from my focal point to my directrix, it'd be up 1, 2, 3, 4, 5, 6. So 6 from focal point to directrix, I only need half of that to get to the vertex, meaning my focal length would be 3. So again, I know the vertex is halfway between. So if I went vertex up 3, I got my directrix, vertex down 3, I got my focal point. So now I know my vertex is 3, 2. So I can put it into that equation again, 1 over 4p, x minus h quantity squared plus k. So it'd be y equals 1 over 4 times p would be 1 over 12. X, opposite same. So it's positive 3, so it goes in as negative 3. Positive 2 goes in as positive 2. I would lose 1 point because I forgot to sketch my parabola. What would I lose another point for? Go ahead, Alexis. Negative. I would encourage, as soon as you see it's concave down, draw yourself a giant negative and circle it. If you don't have the equation, that would be this entire problem flipped upside down. All right, let's try one more. Flip the page for me and go to number 12. Try number 12, beginning to end. Please know at home, I need to see this on Desmos on slide number 4. It's kind of like your exit ticket. I need to see what you understand, what do you still not understand at the end of a class. Please know your homework tonight will be graded on accuracy. We're starting our new unit tomorrow. If you need or would like one of the new packets, if you are virtual, please know they are in the main office. But we're starting our new unit tomorrow, so tonight's homework is graded on accuracy because I need to see what you learned with this short mini topic. Did I get you guys the new packets? Yeah. I did? Did you get one? The blue ones? Yeah. Paul, did you get one? Yeah. You did? See what you can do, beginning to end. Make sure you're challenging yourself. Try something. So again, please be aware that there are still a few of you that never logged into Desmos today. Please know you're not getting the classroom credit. If you're not submitting anything, and especially if you're not logging in, you're not getting that credit because it's like you're not even in class. If you finish number 12, you can go up to number 11. Again, please know your homework this evening is a PDF. It's not in your packet. If you want to do it in the back, you can do it in the back.